Let's take a look at polyvalent ions. As the name implies, these are the ions that can form with more than one valence. And what they really mean there is more than one charge. In fact, this is far more abundant than you might guess. I mean, these group 1s here are always group 1. We call those monovalent. They don't vary from +1 ever, to my knowledge. Neither do the group 2. They always form +2. The halogens tend to be almost always -1, but there are exceptions. I mean, even the noble gases have been found to bond under incredibly rare circumstances. But there's a large region in here for which the charges can be numerous. And for those, we call them polyvalent. For example, titanium can be +2 or +4, or perhaps even some other things more rarely. And so we need to understand why, and we need to understand how to name these substances. The reason why usually involves unfilled inner shells. In other words, even vanadium here has 2 electrons in its valence shell. That's the 4th shell. But when we drop back down into the 3rd shell here, and do you remember that we do that to go into the D block? It can hold 10 electrons there, but it's unfilled. This leads to a somewhat unpredictable situation. You cannot use a simple valence electron analysis to say, this is always going to be +2, because after all, it may desire some electrons at this point, or it may desire to lose some electrons at this point in order to get a full outer shell or something that approximates it. Scientists usually at this point don't go into predictive tools. They simply say, find out what the compound is and name it. So that's typically what we will do. They have close energy levels. They have unfilled inner shells. We name them simply by including the charge. Think of this as something that makes it easier. For example, titanium 4 chloride. You see that Roman numeral 4? That's the method that's used to name the charge on titanium for this particular substance. Therefore, it must be TiCl4. You can use the drop and switch method, put your +4 over titanium, put your -1 over chlorine, and drop and switch. Or you can just simply think about what the charges must be and how they relate to the formula. And so we would call this titanium 4 chloride. If you asked for titanium 2 chloride, this would be TiCl2. And on a given shelf in a stockroom, you might see both forms of titanium chloride. You can see why you really need to include the charge so you can differentiate between them. Here's another example, iron 2 cyanide. So the iron is +2, the cyanide is -1. We do need to use our parentheses here in order to specify this as Fe parentheses Cn taken twice. This does sometimes lead to people taking this too far. For example, tell me the name for NaCl. Please avoid saying that this is sodium 1 chloride because these are not polyvalent. We could simply say sodium chloride is enough. This is a little bit about polyvalent ions.